Welcome to this explainer. Let's just jump right in, because today we are looking at a literal collision course between two of the most dynamic forces on the planet right now, artificial intelligence and our global power grids. You've likely seen the endless headlines about how advanced these foundational AI models are getting. But what is heavily under-discussed and absolutely crucial is the physical muscle required to keep those digital brains running. We're going to dive deep into how the massive energy demands of modern AI data centers are forcing a rapid, necessary engineering paradigm shift across our entire energy system. We are essentially moving completely away from older methods of energy storage and being forced to adopt entirely new frameworks. It's a massive transformation. And by the end of our time today, you'll understand exactly how AI is effectively rewiring the energy sector right from the ground up.
To really grasp the urgency here, you have to look at the mismatch in evolution. We are basically trying to run tomorrow's technology on yesterday's infrastructure. The power grids that deliver electricity to our homes and businesses, they were built over decades, and they were specifically designed for predictable, cyclical human behavior. But the explosion of AI technology definitely isn't waiting for the grid to catch up. Energy demands are evolving at a breakneck pace, and our physical grid infrastructure simply can't match it right now. You might think the fix is just generating more power. Actually, scratch that. It's not just about generation anymore. The real engineering shift is fundamentally a problem of storage duration. Power markets are being tested in ways they literally never anticipated, and grid operators are now sprinting to figure out how to handle an entirely new, unyielding kind of power consumer.
So what's the catalyst for this unprecedented surge? It all comes down to continuous high-load clusters. Now, we aren't talking about your typical server farms processing basic web traffic or routing emails. When a tech giant spins up a massive new artificial intelligence model, that system doesn't sleep, it doesn't take a lunch break, it's a relentless 24-hour-a-day, 7-day-a-week draw on the grid. These are operations that demand constant, uninterrupted power just to push through trillions of parameters. And that single word, continuous, it completely breaks the traditional math for how grid operators project load profiles and supply electricity. It creates this heavy baseline of demand that just never, ever drops off.
And that brings us right to the root of the bottleneck. Historically, energy storage on the grid relied heavily on standard 2 to 4 hour peak shaving assets. The logic used to be super simple: deploy short-term batteries to handle temporary spikes in demand. But think about it. How do you use a 2-hour battery to support an AI training cluster that never powers down? Well, you can't. The tools built for yesterday's temporary energy peaks are fundamentally useless for today's continuous AI plateaus. When the load never recedes, those short-duration batteries are essentially drained in the blink of an eye, leaving the entire data center completely exposed.
Because that short-term storage falls drastically short, the industry is being forced into a rapid evolution toward long-duration energy storage, or LDES. We are talking about major, multi-hour, or even multi-day systems here. Consider this. If your billion-dollar AI data center runs on wind and solar power, the training algorithm absolutely does not care if it's cloudy for a long holiday weekend. The AI is going to demand power regardless of the weather. So we desperately need multi-day LDES systems to bridge those deep gaps in renewable generation, ensuring that the grid remains stable and the electricity keeps flowing to these massive computing clusters without a single interruption.
The whole paradigm has completely shifted. Designing energy storage used to be this careful balancing act where the main goal was really just smoothing out the intermittency of renewables so the local lights wouldn't flicker. But AI has raised the stakes entirely. As the industry now recognizes, designing the right duration profile is no longer just about smoothing intermittency, it is about guaranteeing uninterrupted uptime for critical digital infrastructure. If a modern data center loses power, it's not just a minor glitch. Millions of dollars in computational training time can literally go down the drain, and the hardware itself can be subjected to damaging thermal shocks. The energy sector's core mission has pivoted from simply absorbing grid fluctuations to providing absolute bulletproof reliability for the digital economy.
We know for sure we need longer storage, but the industry is currently locked in a massive, high-stakes debate over the economic sweet spot. Are 6 to 8 hour systems enough to get by, or do developers have to bite the bullet and jump straight into multi-day LDES solutions? It is a giant puzzle. Building out a robust 6 to 8 hour lithium-ion storage facility is already a massive capital expenditure, but engineering a system that can store utility-scale power for 3 full days, that involves entirely different chemistries, complex mechanics, and monumental financial risk. Energy professionals and investors are actively crunching these numbers right now, trying to figure out which duration profile actually makes economic sense without compromising the ruthless uptime demands of the tech sector.
To guarantee this kind of ultra-reliable power, energy professionals are essentially juggling 3 strategic challenges all at once. First, they have to bridge those deep renewable generation gaps, finding ways to store massive amounts of clean power for when generation naturally dips. Second, they have to maintain baseline grid stability so that a massive AI data center doesn't inadvertently black out the surrounding residential communities by drawing way too much current. And third, they have to guarantee that absolute uptime for the data center itself. Solving any one of these is incredibly tough. Solving all three at the exact same time, while navigating physical grid constraints, that requires a total reimagining of global power generation and deployment.
As we wrap up this explainer, I want to leave you with a fascinating paradox to chew on. We know the shift to long-duration energy storage is monumental, and we know exactly what the tech sector is demanding. But what if we simply aren't fast enough? If we can't solve these strategic storage challenges in time, will our physical, aging grid infrastructure become the ultimate ceiling on AI innovation? It's pretty wild to consider that the most advanced, invisible, cutting-edge digital technology in human history might find its ultimate limit dictated by our ability to store electricity in physical batteries. Keep a really close eye on the energy sector. It might just dictate the entire future of artificial intelligence.